Welcome back to this Alibaba Cloud certification course. In this section, we'll be discussing OSS, or Object Storage Service. We'll first talk about what OSS is, then we'll discuss basic OSS concepts. We'll move into a demonstration of bucket and object management on OSS. We'll discuss image processing. We'll take a look at how to do website hosting and monitoring on top of OSS. And we'll talk about some hosting-related concepts like custom domains and our anti-leeching features. And then finally, we will wrap up with an explanation of OSS's security model. Let's get started. So let's start at the very beginning. What is OSS? How does it compare to other methods of storing data? So the traditional way in which files are stored is on a file system. In traditional file storage, there is a nested hierarchy consisting of files and directories, and there's a file table to keep track of the relationships between these files and directories to maintain this hierarchy. A typical file storage solution or a file system will run on top of block storage, which could be a traditional hard drive or a solid-state drive. Object storage differs from file storage in that there is no hierarchy. There's no concept of a directory. Each object is represented by a key, and each key maps to a particular location within the object storage system. Hence, there's a table of key value pairs mapping object names to object locations within the object storage system. A major advantage of having this simple one-dimensional key value mapping is that object storage systems can scale flexibly. You can add capacity to an object storage system very easily without having any impact on files or objects that are already stored within the system. Traditional file storage requires the maintenance of a file table that records the relationship between files and directories, and typically there's a maximum size limit on file storage systems. Object storage doesn't have that limitation and can essentially grow infinitely. So let's take a look at some traditional storage system pain points. Let's say you're developing your own off-cloud storage solution. Well, the first thing you're going to need to do is buy a storage server. This could be something like a SAN device from a company like Dell or EMC. What happens when the volume of data increases? Well, you have to buy more storage equipment. And it's very difficult to predict in advance how much space you're going to use. And you have to make sure that you plan to have overcapacity. You need to have more storage available than you actually need to make sure that you don't run out. So you have the expense of buying this equipment up front and doing your best to try to guess how much capacity you're going to need. So you have to evaluate new storage capacity, figure out how much space you need for data backup, figure out how you're going to handle data security, and most importantly, since you have to plan in advance, you have to try not to buy too little equipment and run out of space, but you also need to not buy too much, so you have to worry about cost control. With OSS, you don't have these concerns. That's because OSS can scale transparently. So OSS scales in the background without you needing to think about adding capacity. You're charged only for the storage space you use on OSS, and you can scale up or down as often as you need. So OSS wins versus traditional storage because you can store an enormous number of files easily without worrying about how scaling is done. That happens in the background. You get enterprise-grade security. That means encryption in transit, encryption for files at rest. You get high availability. This is the same system we use internally for a lot of data storage at Alibaba. So we maintain its availability. It's a very high availability service, and it's pay as you go. If today you need 10 gigabytes of space, and tomorrow you need 100, and then next month you only need 10 gigabytes again, no problem. You pay only for the space you're currently using. So what are some of the advantages of object storage? Well, one of the big ones is scalability. A single OSS bucket can hold up to 50 petabytes of data and an essentially unlimited number of objects. Simplicity is another key advantage. The OSS service provides a simple RESTful HTTP API, which is accessible from anywhere, anytime. It is in fact a public internet service. Object sizes can vary between 0 bytes and 48.8 terabytes. We have multiple upload methods: normal upload, multi-part upload, and append, which allows you to add data to an existing OSS object. The OSS service is a fully managed service. There's no patching for you to do, no operating system for you to worry about. All you need to do is interact with the OSS API. There's built-in monitoring, metric support, and access logging as well to help you keep track of your OSS usage. In the security department, OSS provides multi-layer protections, including anti-DDoS protection up to 5 gigabits per second, multi-user isolation, and comprehensive logs to help you trace malicious access. Availability is another key advantage. All data in OSS is stored across 3 different physical servers attached to 3 different network switches, so all data is stored in triplicate. That gets you 11 nines of data reliability and 99.99% service availability. And of course, the OSS service expands or grows its storage capacity automatically, so you don't need to worry about how that's going to be done. And if you choose to turn on cross-region replication, it's even possible to make copies of all of the data within a bucket into a bucket in another region, so your data can survive the failure of an entire region. And finally, there's inclusiveness. OSS integrates with both a variety of Alibaba Cloud's own services and can easily be integrated with third-party applications via its open HTTP API. We'll now discuss some core OSS concepts. So OSS is an important part of the Alibaba Cloud platform, and just like the rest of the Alibaba Cloud public cloud platform, it depends on Apsara in order to run. So Apsara is our cloud management system. The boxes in orange here in the architecture diagram on this slide are the components of the Apsara system. In particular, OSS depends heavily on Pangu, which is the distributed file system component of Apsara. The way that OSS is able to store data in triplicate is part of the Pangu architecture. OSS is supported across all 22 Alibaba Cloud regions and all 66 of our zones worldwide. So wherever you are, you'll be able to find OSS within your closest Alibaba Cloud region. The 2 most important concepts to understand in OSS are the object and the bucket. So an object is essentially a file. This is the fundamental entity that you store inside your OSS buckets. So an object has 3 parts: the key, the data, and the metadata. The key is essentially the object's name. It's like a file name. It has to be unique within a given bucket. The data is the file content for your object, and then the metadata is a set of key value pairs that expresses the object's attributes. So this could be things like a checksum, the size of the object, the last time it was modified, etc. The data portion is opaque to OSS and is not manipulated by the OSS service except to store it onto disk and retrieve it when you request it. The size of an object varies with the upload method. Multi-part upload supports up to 48.8 terabytes for a single object. However, if you're using our traditional HTTP upload methods, then the object size is limited to 5 gigabytes. So do keep that in mind. If your objects are larger than 5 gigabytes, you need to be using the multi-part upload tool. Next, there is buckets. So buckets serve as the containers that hold the objects you store in OSS. Every object must be kept in a bucket, and each bucket name must be globally unique within the OSS service and cannot be changed. What that means is that if another user is already using the bucket name that you want to use, you will have to pick another name. Bucket names, even between users, cannot overlap. They really must be truly globally unique. We'll talk about why that is later on. There is no limit on the number of objects in a bucket. An application, so a third-party application that you write or the Alibaba Cloud command line, can talk to more than one bucket. So you can communicate via the OSS API with each of your buckets. Buckets are how we organize the OSS namespace at the highest level, and they're also how we do usage reporting and access control. So each object within a bucket has a key. The key is an object's unique identifier. The combination of the bucket name and the key uniquely identifies any object within the entire OSS service. And if you look at the URL here on this slide, you'll see why that is. The bucket name plus the bucket endpoint, which is the API endpoint for the OSS service, plus the object name, these 3 components in orange, blue, and red respectively, form a URL. This is also the reason that bucket names must be unique. They are part of a resolvable DNS name that points to your bucket and its content. So they really genuinely have to be unique because they have to resolve via the worldwide DNS service to a particular location. So if you combine the protocol, HTTP or HTTPS, plus your bucket name, plus your bucket endpoint, which varies, each Alibaba Cloud region has its own bucket endpoint, plus the object name, if you take these 4 things and combine them, you get a URL that points at a particular object within a particular bucket, and that URL is unique globally. So the URL points to just your object and only your object. Object keys, they can be up to 1024 bytes in length. The encoding we use is UTF-8, so the object name can include characters from other languages like Japanese or Chinese. The object key has to be unique within a given bucket, but of course if you have more than one bucket, each of those different buckets can contain objects with the same names. Object keys can contain a path prefix. Because Object Storage Service does not have a concept of a directory, what you can do instead is simulate having nested directories by adding path prefixes to your bucket. So you can see there's an example in the bottom of the slide here in green. This is an object that has had some directory path prefixes added to the beginning of the name. So the original name of the object was just jtables.js, and they've added 1, 2, 3, 4 levels of path prefix. So if you were to actually go into the OSS console and try to find this object, the OSS console would make it appear to you as though there was a directory called assets with a directory called JS inside. Inside there would be a jQuery directory. Inside there would be plugins. And inside plugins, you'd find jtables.js. But if you were actually to use the API or the command line to try to fetch this object, the object's name or key would just be assets/js/jQuery. There's no actual hierarchy here. It's just a simulated directory hierarchy that's created using these path prefixes. So this is what the data structure on OSS looks like. At the top level, there's buckets. Within buckets, you have objects and simulated directories, which you simulate using the path prefixes we just discussed. And of course, each object has its three components: its key, its data, and its metadata. So data stored in OSS is stored in one of several different storage classes, and these range from hot to cold. Here I've arranged them from left to right on this table. The hot storage classes are designed for data that is frequently accessed, whereas the cold storage classes are designed for data that is infrequently accessed. So you can see there's a column at the middle of the table called retrieval time, which lists how long it typically takes to retrieve data. So archive, it can take up to a minute to retrieve data. With cold archive, depending on whether or not you pay for expedited retrieval, it can take between an hour and 11 hours to retrieve data. However, the advantage of those colder storage types, like archive, cold archive, or infrequent access, is that the cost per gigabyte is lower. However, for infrequent access, archive, and cold archive on the right side of my table, you do pay a retrieval fee for requesting data back from the service. So that's an incentive to not query the service more than you need to. With standard storage, which is our typical default storage class for OSS, there's no retrieval fee for requesting an object from the service, so this is really the best choice for frequently accessed data. You'll also notice that for standard and for infrequent access, we've actually got two different types. One is called LRS and one is called ZRS. So the difference between LRS and ZRS has to do with how the triplicate copies, the 3 copies of your data, are stored. So in standard and IA LRS, so in local redundant storage as we call it, all of your data is stored within a single Alibaba Cloud zone. So the 3 copies of your data are on separate physical servers attached to separate network switches, but those physical servers live within the same data center. That is already good enough to get you a data durability of 11 nines and 99.99% service availability. However, if that isn't high enough, you can choose standard or infrequent access ZRS. ZRS is zone redundant storage. In zone redundant storage, we keep the copies of your data in different zones. This means that your data it will still be available even if a single zone within a region fails. That gets you 99.995% service availability and 12 nines data durability. So if you really need the ultimate availability and durability for your data, then ZRS, zone redundant storage, is the right choice. Not all of the objects within a bucket need to belong to the same storage class. You can set what are called lifecycle rules within a bucket that will determine what happened to OSS objects at various points in their lifecycle. So when should objects transition between storage classes? You can set a rule that takes older objects, maybe objects that have been in your bucket for 60 days, and transitions them to IA, infrequent access storage, in order to save money. The lifecycle rules can also determine when objects should be deleted from the bucket and what patterns an object must match in order for a given rule to take effect. In order to achieve better redundancy and fault tolerance, in addition to zone redundant storage, or ZRS, which we just discussed, there's also versioning and cross-region replication. Versioning is fairly simple. When you turn on versioning for a bucket, each time you upload a new copy of an object, instead of overwriting the previous copy of that object, the previous copy is given a version number and hidden in the background, but it's kept in the bucket, and you can retrieve or restore old versions of an object at any time by checking the version history. This way you can preserve changes that have occurred to objects over time. Cross-region replication allows you to copy all of the content of a bucket to another bucket in a different region. So for instance, if I had a OSS bucket in Hong Kong and another OSS bucket in Singapore, I could set up CRR on the Hong Kong bucket so that each time an object was uploaded to the Hong Kong bucket, it would also be copied over to the Singapore bucket automatically. This is a great way to achieve multi-region redundancy. OSS also has some built-in features that are designed for web hosting scenarios. One of those is what we call back-to-origin mirroring. In this case, when a client, it could be a web browser or a command line tool or a third-party application, when a client requests access to an object in OSS, if OSS doesn't have a matching object, it will send a request back to some source website or source service, and if the object is found at that source, it will make a copy into OSS and then return that copy to the client. This can transparently achieve mirroring of data that's stored outside of OSS. Similarly, OSS supports redirection. So if a client requests an object that's not stored in OSS, OSS can send back a redirect directive, and the client can then go fetch the object from some other source. Again, this is a web hosting related feature that can help you to deal with some common web hosting scenarios. OSS also has built-in logging and log management. You can turn on logging for a given bucket and then have those logs stored into another bucket, which we call the destination bucket, under a particular path, which we call a log prefix. You can then retrieve those logs anytime you want to perform analysis or security checks or audits. You can see an example of such a log entry just under the access logging section on the left side of this slide. You can see it includes the source IP address, the timestamp, the type of HTTP request that it received, the flags associated with that request, and the operating system of the requester. If you want to have the ability to do real-time full-text log search, you can also turn on the real-time logging feature. In addition to recording access logs, this actually indexes the logs and makes them searchable, so you can easily search through the logs using our real-time log GUI. And that's all for this section. Let's now take a look at how you create and manage an OSS bucket. So I'm here on the AlibabaCloud.com homepage. I'm going to go over and click on console, and then we'll go over to the OSS console. So right now I'm on the Alibaba Cloud console homepage. From here I need to navigate over to OSS. So how do I do that? Well, I take my mouse and I mouse over to this orange and white menu button here. A menu will pop out from the left-hand side with products and services at the top. When I mouse over that, a search bar will open up, as well as a product list listing all of the products currently available on the AlibabaCloud.com website. And I'll type in OSS to search for and locate Object Storage Service. When I click on that, I'll be directed to the OSS console. And you can see, unlike the ECS console, the bucket list and the overview page in OSS are both global, so there's no regional selection up here. All your buckets, no matter where they are in the world, are all listed in one place, and you can see that the region in which the bucket is located is one of the items here in the bucket overview list, so you can get an idea where your buckets are located. In fact, you can even sort by region, by storage class, and by bucket name if you want to make this list a little bit easier to navigate. So let's go ahead and create a new bucket. So I'll click on Create Bucket. That will open up a menu where I can choose a bucket name. Remember, your bucket name has to be globally unique, so I'm going to try to choose a name that nobody else has chosen. Once I do type in a name, the service will tell me whether or not it's taken. You can see here, after I've typed in JDP, the service indicates that this bucket already exists or is in use by another user, so I can't take that name. So I'll call it JDP test bucket, which should be okay. Yep, that's not taken. And I'm going to use Singapore as my region. And you'll note that here I can choose my storage class. This is the default storage class for the bucket. I can choose either standard, infrequent access, or archive from here. In my case, I will stick with the default of standard. That means any objects I add to the bucket will have the storage class standard. They'll use the standard OSS storage class. If I want, I can have some of the objects in the bucket live within a different storage class. There's no rule that all of the objects must be in the same storage class. Objects within a given bucket can be in different storage classes. That's not an issue. In fact, when I configure lifecycle policy for the objects in my bucket, a natural result of that will be that when objects reach a certain age, they will be moved to another storage class. So I might have some objects in my bucket that were recently added, still in the standard class, and some objects in the infrequent access or archive class instead. In my case, for the demo, I'll just be keeping everything in standard. I can turn on zone redundant storage if I want. Again, this gives me better durability and availability by spreading the copies of my data in OSS across multiple zones within a single region. I will leave that disabled, but if I wanted to, I could turn that on. Versioning, again, if you upload a new copy of an existing object to your bucket, with versioning disabled, the new copy will overwrite the old copy of the object. The old copy of the object will be lost. However, if I turn on versioning, then when I upload a new copy of an existing object, the old copy is kept in the background and tagged with a version number. And this way, I can build up a version history for the objects I'm uploading into my OSS bucket, and I can restore or revert to one of those old versions of the object later if I want. This is an especially valuable feature if you're using your OSS bucket maybe to store code, or maybe to store Terraform files, or something where you want the ability to go back in time and potentially restore an old version. Access control, there are 3 types of ACL for buckets: private, public read, and public read write. So with private, all requests, either to access an object or to update or upload a new object, must be signed. So with private ACL set, every request I make to the OSS service has to be signed, proving that I have permission to access this bucket, that I'm a member of this Alibaba Cloud account. With public read, requests to upload or write data into the bucket must be signed with a STS token, but requests to read can be anonymous. So if I set my bucket as public read, I can easily take the URLs for the objects in the bucket and say, embed them into the HTML for a web page. And then when a user's browser loads that page and requests those resources, it will directly be granted access rather than having to sign the request with an Alibaba Cloud key. Public read write does the same thing, except reading, deleting, and writing objects is all allowed anonymously. This is quite dangerous. I don't recommend that you use public read write in practice. Public read is appropriate for some types of website or web application, but for the most part, you should stick with the default and use private here. Encryption, again, there's 2 types: OSS managed. This uses the AES 256 key that's built into the OSS service. And then there's KMS, which uses a key that you've created yourself inside of our key management service. I'll choose none for this demo. I won't enable encryption at all. If I'd like, I can set up a scheduled regular backup of the content of my OSS bucket. I can use our hybrid backup recovery, HBR service, to do this, and that will take regular snapshots of my bucket. I'm going to leave that disabled, but I will turn on real-time log query. So what real-time log query does is it allows me to search through a full-text index or archive of all the log events that have happened after I've set up my bucket. So when someone adds a new object or makes a request, I can see all that information via the log query window. Okay, so let's click OK and create our bucket. So after waiting a second, our bucket is now ready to go. You can see it's empty right now. No requests this month, 0 bytes of traffic, 0 storage use. I can get some basic information here about the configuration of the bucket, and I can change configuration for any of these by clicking on Configure. Same thing for these. For instance, if I want to enable ordinary logging, which backs up logs to another OSS bucket, I can do that. I've already got real-time logging turned on, so I'm not going to turn that on. Lifecycle, I can configure that. I can create a rule here that will say move objects that are older than 60 days to IA storage. And then I can click OK, and then we'll say we'll delete objects older than 180 days. You can also choose to delete an object as well. So I'll say OK, and now objects at 60 days get moved to IA, and at 180 days they get deleted automatically. So now I have lifecycle rules set up, and these rules will take effect within 48 hours of having been created. So I do have to wait a little bit for those rules to take effect. Now let's go ahead and upload some objects to our bucket. So I will upload maybe a picture. So let's go to my downloads folder, and I will choose from the images folder this bunny. And I'll click open. And now I've uploaded this bunny. I can now click on removed to clear this upload task list. Don't worry, that doesn't delete the object, it just clears out this task list. And then here's my bunny object. Great, that's it. That's how you set up and manage a bucket. For additional settings, you can look in access control. This lets you set bucket policy, set access control lists, determine what RAM roles are allowed to access the bucket, and turn on cross-origin resource sharing or hotlink protection, which is especially useful if you are using your OSS bucket to host web content and you only want certain sites to be allowed to link to that content. Bucket policy, let's have a quick example. If I click configure and I click authorize, I can start creating policies. I can apply them to specific resources within the bucket or to the whole bucket, and I can make the policy apply to RAM user accounts, other Alibaba Cloud accounts, or anonymous accounts. And what I can do is decide what operations are authorized and under what conditions. So for instance, if I were to make the whole bucket read-write for an anonymous account from a particular IP, then when I access the service from that IP, I do not need to sign my requests. I'll be allowed to anonymously access all of the items in the bucket and also read, write, and delete those items all without proving my authentication or identity, just because I'm coming from this IP address. If I came from some other IP address, then I would be asked for an STS token to authenticate me. Okay, and one other thing we should look at, basic settings. Here I can adjust server-side encryption settings, set up static web hosting, set up bucket lifecycle. I can tag my bucket, which makes it easier to sort my buckets and also read my bill. I can set up back to origin, which will fetch objects from some other web address if an object is not found in the bucket. You can use this as a way to do transparent mirroring of some origin site. I can trigger notifications when certain operations are performed so that I can track access to my bucket. And I can also turn on what's called pay by requester, which is where the person requesting the object or objects from my bucket has to pay for my network bandwidth. And so the data and the traffic fees are charged to that other person. Obviously, in order to configure that, the other person needs to have an Alibaba Cloud account. And then I can set up a retention policy as well, which will allow me to configure what we call WORM, or write once, read many, which means I can set up a bucket for compliance in which it's impossible to delete objects before a certain time frame has passed. This is a great way to enable very solid hack-proof auditing. And then I can also do something called bucket inventory, which will create an inventory list of the objects in my buckets, which is great for auditing and verification. And then the final setting, I can delete my bucket. But before we do that, now that we've got a file in here, let's try visiting it, and then let's see what logs were generated. So I'll click on bunny.jpg. Here we go. Copy file URL, and you can see it's got a time-limited access key or signing key built into the URL here. That key is valid for 300 seconds. When I copy the file URL and paste it into a new tab, the image loads. And if I were to wait 300 seconds, this URL would become invalid because the time to live for this key would have passed. So let's see if I can see that access request in the logs. So let's go down to logging and we'll go to real-time log query. And here we have a nice dashboard where we can see the last 7 days worth of logs. And you can see currently there's a few requests showing up already. This isn't quite in real time, but it's close. Let's take a look at this one here. So 16 occurrences, let's see what happened. So this is probably our access request. Let's click on that and take a look. So what we're looking for is a GET request. So let's take a look for HTTP method GET, and you can see that we attempted to access what? This bunny object. And sure enough, this is the signing key we used. And we can see some information about the time that the access took place, the IP address, we can see the result, access denied or successful, and we can see the user agent. So you can tell that I actually tried to access this item from a browser on a Mac. So you can get a lot of information out of the logging dashboard that's built in when you turn on real-time log query. And that's it for this demo. Let's now briefly take a look at how we can manage the objects we upload into our OSS buckets. So we previously uploaded this object bunny.jpg. Let's click on View Details and see what information we can find out about this object. So if I click on View Details, I can see a preview of the item. In this case, it's an image, so there is a preview. Other file types may not support preview. For instance, zip archives don't support preview, images do. I can see the file name or object name, some metadata associated with the object, and I can see that because the bucket ACL is private, the URL for this object, the URL to access this object has a signing key, which is valid for 300 seconds. And of course, I could change that, make it valid for 60 seconds, or even make it valid for a longer period, like an hour. Let's make it valid for an hour. And then I could download the object or copy the URL to access the object in order to view it, say, in a web browser. So if I were to click on Copy File URL and open a new tab and paste it in, then sure enough, I can see the object. And if I try removing the signing key, you'll see that now access is denied. It says you have no right to access this because of bucket ACL. If I wanted, I could change that from here. I can also set HTTP headers for this image if I want, and I can set the ACL for this individual object to be public read. So the bucket itself is private, but I can change the ACL of individual objects within the bucket. And you'll notice that once the ACL for the file is public read, then the URL no longer needs a signing key. So if I go back and try that request again, it now succeeds. I can also simulate having folders or directories in the console. If I click on Create Folder, I can simulate having a folder here. What will actually happen is if I upload an item into this folder, the item name, the object name, will actually have my folder / appended to the object key. So the object's name will actually include my folder and a /. Let's try that. So I'll click on Upload. And again, we'll choose to make the file ACL public, even though the bucket is private. And this time I'll upload a kitten. So there we go, I've uploaded a kitten. I'll clear my task upload list, and we'll look at the information here. I get a nice little preview, and you can see that there's no signing key in the URL. I can copy that file URL to the clipboard, paste it into the browser, and sure enough, I can visit this item. I can directly fetch this image from my bucket, no problem, without a signing key. If I wanted, I could set the ACL back to inherit from bucket, and now to view the object, I have to start signing my requests again, like so. And you'll notice, actually, that if you look closely at the request, it actually includes /myfolder/kitten. So that's actually part of the object name itself. It's not something that's actually representative of a real folder, it's just a path prefix. But it does allow you to simulate folders and directories, which is a very nice feature. You'll also see that if you click on More, you have options to tag objects within your bucket, set their headers, set soft links, configure object ACL, download objects, or delete the object if you so choose. You can also modify the storage class. For instance, I could directly move this bunny image to IA storage. I won't do that though, I'll leave it the way it is, and I'll click Cancel. And that's it for the demo. Let's now take a look at OSS's built-in image processing capabilities. So the OSS service includes the ability to process images in the background in a serverless way at high capacity and with high reliability for any image that is stored in an OSS bucket. So in order to do this, you upload an image to OSS, you append a tag to the URL pointing to the image, and then a new image is produced and sent to you when you make a GET request, say via a browser or via the command line. The functions we support include converting image formats, scaling, cropping, and rotating, and adding text or image watermarks. You can also apply color effects, and in fact you can combine these effects together into what is called a style, and then invoke that style as a URL parameter. The way this is done is by appending the x-oss-process query string to the end of the URL. So of course you have your bucket name, endpoint, and object, and then at the end of that you append this x-oss-process query string, and you can either directly call built-in operations like resize, or you can call a style A style is a set of image processing tasks that you want to perform together. So you can give a style name, and then append the style name after the OSS process query string to call that style and produce a processed final output image. So rather than just talking about this, let's go ahead and try it out. Let's have a quick demo in the console. Let's go ahead and create an OSS bucket. So what I'm going to do is click on console here, and then we'll enter the console. This is the console homepage. From here, I will mouse over to the top left. As soon as I put my mouse over this orange button, this menu will pop open. I'll mouse over products and services, and that will open the product and services list. From here, I can search for OSS. Down here under storage and CDN, you see object storage service. I'll go ahead and click on that, and let's go ahead and make ourselves a bucket. So I'll go to the buckets list. You'll notice that the OSS console records all bucket information globally, so I don't need to switch to a particular region to see my buckets. All the buckets that I have worldwide will show up in a single list here. And you can see I've got a few buckets already from previous demos. I've got a few buckets that are linked up to our data processing toolset, DataWorks. I've got one for recording logs and audit trails under my account. Let's make a new one for holding images so we can try out our image processing functionality. So I'll go ahead and click on Create Bucket, and we need to choose a region. I'm going to go ahead and choose Singapore, and I'll call it JDP Image Bucket. And remember, the name has to be globally unique. So if I choose something like Bucket, it's probably taken. So you can see Bucket already exists, right? Maybe my initials are okay. Nope, someone already has those too. So usually it pays to choose a long descriptive name. It's much less likely to be taken. So I'll go with JDP Image Bucket. And I can choose the storage class, the default storage class for all of the items in the bucket. I can choose either standard, IA, or archive from here. I will stick with standard. Not all of the objects in a bucket have to be in the same storage class. The default when I upload new objects will be standard if I choose standard here, but I can use Bucket Lifecycle to take certain items and place them into IA or archive. Zone redundant storage, if I turn this on, I will get higher availability and data durability. I'm going to leave it disabled because I'm just doing a demo. Versioning, if I turn this on, when I upload newer versions of an existing object, then instead of being deleted, the old version of the object will be stored and tagged with a version number. Again, I'll leave that disabled for this demo. Let's now go look at the encryption options. So I have three options: None, OSS Managed, and KMS. If I choose OSS Managed, then all of the items in my bucket will be encrypted with an AES 256 key that is managed by the OSS service on Alibaba Cloud. If I want to use my own key, I can create a key inside of our key management service and then assign that key to the bucket. Of course, I don't currently have a master key, so that won't work, so I'll just go with OSS Managed to use the built-in key. If I wanted to use KMS, I would have to go to the KMS console and set up a new key over there. Let's turn on real-time log query. This way, I can show you log results for requests I make against the bucket endpoint for this bucket. This is not required, this is optional, but by turning it on, all of my logs will be stored. All of my logs of the last 7 days will be stored free of charge, and I'll be able to do full text search on those logs. And if I want, I can actually also turn on scheduled backup for my bucket that will use our hybrid backup and recovery service to take all of the data I've stored in OSS and make a snapshot of it via HBR. I'm going to leave that disabled. So I've now set my bucket up the way I want, and I can click OK, and the bucket will be created. Once the bucket is created, we can navigate into the bucket and try uploading some data. So that will be next. So here's our bucket. It has been created. You can see versioning is not turned on. The access control list is private, so you cannot access this bucket without a signing key. You need to authenticate first. And the retention policy is set to disabled. Let's go ahead and make some changes. First of all, I want to change the ACL. I want to change the bucket policy from private to public read. I want to make the contents of the bucket available publicly. So I'll click continue here. I've received a warning me that public read means anyone can access the bucket without authentication. That's fine. This is what you will typically choose for hosting a website or hosting images that need to be downloaded to a user's device, because this way you don't need to sign your URLs. So I'll go ahead and choose public read and click save. You can also see I can set what's called a bucket policy here. This allows me to have further fine-grained control over the bucket. So if I click Configure, I can add an authorization policy here by clicking Authorize. I can apply it to specific resources in the bucket, say by following a particular directory prefix, or to the whole bucket. And I can say who the policy applies to. Does it apply to other Alibaba Cloud accounts, to RAM users under my account, or to anonymous users? And of course, if you choose anonymous, you receive a warning, because applying a policy to anonymous users means those users may be able to access the bucket without authentication. I can then say what operations are acceptable, none, any operation, read write, or read only, and I can set conditions. So I can set IP whitelists or blacklists, or I can set conditions on the access method. For instance, I can say this bucket is only accessible to users over HTTPS. I will leave the bucket policy blank. I will not create any policies at this time. And then, of course, once you have created policies, you may want to go over to the RAM console and set up some RAM users that inherit those policies. So now that we've changed our bucket ACL to public read, let's insert some files into our bucket and do some image processing tasks. So let's go find some images. So we're now ready to go ahead and upload some images. So I'll click on Upload here. There are multiple ways to upload images. I don't have to do this through the console, through the web console. I could also do this through the command line. I could use the Aliyun CLI command line tool, or I could use our multi-part upload tool, which is designed for larger uploads. In this case, for convenience, I'll just use the web console. So I'll click on Upload, and you can see here I have the option to actually change the ACL for this object. So if I inherit from the bucket is set to public read right now, so all the objects I upload will also be public read, but I could choose private or public read and write. I'm just going to leave the default setting of inherit from the bucket, and I'll go ahead and click Upload, and I've got this images folder here, and I've got a bunny and a kitten. So let's go ahead and upload both of those, and you can see they are now both uploaded. There's a little progress bar that will show up here, or a percentage that will show up here that will tell you how the upload is going. Unfortunately, you couldn't see it this time because these images are very small, so the upload was quite fast. If I want, I can actually hit this confusingly titled button here. It says removed. That will actually clear this list. It will not actually delete anything from your bucket. It will just clear the list of upload tasks. So you can see both of those images are now here. If I click on one of these images, I will get a preview of the image, some information about its file name, some information associated, some image metadata that's associated with this object in my bucket, and also the bucket URL for this image. So if I copy this URL and paste it into a new tab, that should actually open up the image in my browser. So you can see that this URL here actually points to this item that I've uploaded. This is a unique URL, globally unique within the OSS service, and I can use this to fetch this object or embed this image into a web page or fetch it from an application. So how do we go about doing image processing? How do I do that? So if I want to add image processing flags, it's fairly simple. So I'll open up a new tab, I'll paste in that URL, and I just need to add that XOSS process query string, and I have to say what I want to do. I indicate that I want to process an image. I'll say I want to resize the width. I'll say I want the image to be 100 pixels across. So let's go ahead and try that. Oops, that didn't work. So it looks like I got the parameter name incorrect here. That's okay. We can try again. Let's fix that and then have another try. Okay, so I see the error. I was off by a little bit here. That should have been resize, comma, and then width 100. So you can see I now get returned to me a smaller version of the image. So that has actually been reduced in size automatically on the back end. The original image in my bucket is still there, and it's still the original size and resolution. That new smaller image was produced for me automatically by the image processing service. I could also choose, say, a larger size like 500 pixels across. And of course I could scale the size of the image in pixels horizontally as well. I could scale it horizontally down to 400 or 300 if I want. It's also possible for me to create a style which combines multiple image processing operations, give that style a name, and then call the style here in the XOSS process query string. So let's try that out as well. So let me close this image, and we'll go down to the data processing section, and you can see there's an option here for image processing. I'll click on that, and I can create a new rule. So let's go ahead and create a new style called caption, and we'll add text to our image. So let's go take a look at some of the effects. I can change the image file format, change the quality, do all kinds of things from here. But what I want to do though is ignore most of this blurring and sharpening and whatnot, and just add a text-based watermark to my image that says, "So cute." And I want that actually, let's make that all caps, "So cute." And I want it to be at the top of the image, and I'd like to change the font size a little bit, and it should be a different color. Let's select white, shall we? I don't see white as an option here. I'll just type in the hex. There we go. And now the text is white. I could rotate the text if I want. I'll just leave it at the top. Text fill. Turn that on, that fills the whole image. Text shadow, that will place a shadow behind the text. That makes it look nice. Let's leave that turned on. And then I'll click OK. And so this is our new style URL. So actually this is what I'm doing. I'm doing auto orient. I'm changing the quality to 90%. I'm adding a text watermark with this color, and I'm changing the size of the text and setting a shadow behind the text, etc., etc. These are the actual parameters that are going to be passed to the image processing service. I don't have to remember all of that though, because after I click OK, my new style will get a name. It's called caption. And so I can actually just do this. I can have the XOSS process query string and then style / style name, in this case, caption. So let's try that. So we'll do that to our bunny. Let's see, style / caption. So cute. So it's the original size, and it has this style caption applied to it, which puts text at the top of the image. We can also do that to our other image. There's no reason we can't try that out on our kitten too. The processing tools will work on a WebP just as well. They work on multiple different image formats. So let's go ahead and try it on this kitten. So here's my original kitten picture, and then I can do XOSS process style caption. So cute, and sure enough it works. And there you go. That's how you use the image processing capabilities built into OSS. OSS website hosting and monitoring. So in addition to the image processing features we previously discussed, OSS can also be used to host a static website. You can upload CSS, HTML, and JavaScript files to your OSS bucket and then turn on the static hosting capability. This is a great way to build a very, very low-cost, scalable serverless site. This will scale to handle almost any load, and because it's entirely serverless, you're really only paying for network bandwidth and storage space used. So this can be an incredibly cheap and efficient way to run your website. So in the settings, you can find a section called Static Pages in the settings for each bucket. Here you set a default 404 page and a default home page. These need to be files that are located in the bucket. And whenever a user visits your bucket, one of these pages will be displayed. If the page they requested is not found, they'll get sent to the default 404 page. If they visit the default home page, that's what will be displayed. And additionally, you can bind a custom domain name. So we'll test that out a little bit later. We'll create a new bucket, upload some files into the bucket, and then try binding a domain name to that bucket. And typically it's a good idea to bind a domain name. It makes your site look much more professional. If you're just using the bucket endpoint, it doesn't look too good. You can also monitor your site. Again, you can monitor key metrics for your buckets via our free monitoring tool, Cloud Monitor, and you can also get interesting and valuable information from the logs. So if you've turned on logging for your bucket and you're collecting logs, you can get valuable information about how many requests you're receiving in near real time. Down at the bottom of the slide here, you can see a few examples of the types of metrics that are available to you. So you can see network error count, network throughput, storage space used, and more. So let's take a look at all this in the console. Let's actually continue to use the bucket we set up earlier for the image processing demo. So we're going to add some HTML files into this bucket. Let's upload those now. So just as I did before, I'll upload the files by clicking on the upload button, and then I'll fetch them from my downloads folder, which is where I saved them. Let's go back to downloads. Here's my index.html and my notfound.html, and we'll upload both of those. There we go. They're now part of our bucket. I can clear the upload task list, and now I need to set up my bucket for web hosting. So I need to go to Basic Settings, and you'll see all of the settings for the bucket are here under Basic Settings. I want to go to Static Pages, and I'll click Configure to set up a default home page and also a default not found page. And I will click Save. And you'll notice there's also an option, let me click on Configure to show that again. There's an option here to put your home page into a subfolder if you want. I've chosen not to do that because both of these both of these files are in the root. They're at the top level in the bucket. They don't have any kind of directory prefix in the object name. So I can just put those names in directly. And now the bucket is ready. So let's see what happens if I try to visit this URL. I think you'll be surprised by what will happen. So let's take a look. So if I go visit this item, if I go visit index.html, the page doesn't display. Did you see what happened? Let me do that again. So what actually happened is the HTML document got downloaded. If you want to display the page directly in the browser, you actually have to bind a domain name to your bucket. So let's take a look at how to do that. And the domain name doesn't have to belong to your Alibaba Cloud account. It could be with a different domain name registrar, but for convenience, I'll show you how to do this from Alibaba's domain name and DNS service. So first thing I need to do is open up a new tab and go over to the domains part of the console. Let's take a look at that. Let's see what domains we have available to use here. So I've got two. I've got function-time.xyz, which I use for testing our function compute service, and chinasite.xyz, which is just a generic domain for doing all kinds of demos. So I'm going to go ahead and take this and use it to go ahead and create a static site. So let's do that now. So I need to go into the OSS Management Console, and again we'll go to Basic Settings. And actually from here there should be a place where I can go ahead and bind that to my bucket. Not in here. It's actually under Custom Domain Names. So if I go under Transmission, there's domain names here. From here I can bind a custom domain name. So let's do that. I'll click on Bind Custom Domain, and I will choose chinasite.xyz. Now because this is under my Alibaba Cloud account, I can check this radio button here to set up the CNAME records that point to my bucket endpoint automatically. So I'll do that. I'll set up a CNAME record automatically here. Let's do that. Click Submit. If I want to check that that has been successfully configured, I can go over to the DNS console. Let's close this tab. We don't need that anymore. So I'll go over to DNS and I'll check the records that are configured for chinasite.xyz, and I can see there's a CNAME record that's pointing at my bucket endpoint there. Let's configure another one for www as well, so that we can have that point to our bucket. So I'll click Add Record. I'll make another CNAME record for www that points at our bucket endpoint, and I'll click Confirm. So now that that's done, I should be able to go to chinasite.xyz, and sure enough, I get cute bunnies and cute kitties. And you'll notice I've actually linked in the HTML, in the index.html file, I've actually set up two image tags that point to the images that are in the same OSS bucket. So those two images, that bunny and that kitten, that I put into my bucket earlier, I can link to those directly from within the index.html file that I've just added to my bucket. So you can put a full static site up here. If you put CSS and JavaScript and image files into your bucket along with your HTML code, you can reference those. So that's what I've done. I've actually referenced these images inside my HTML. In fact, let's go view source here. And sure enough, you can see this is the actual source for the page. And I've just got a relative tag here that points to bunny.jpg, right, which is the bunny file from earlier. And if I wanted, I could change this HTML to actually also apply a query string to this URL to process the image. That's also possible. So I can combine static web hosting with other features like image processing. And that's all for the static site demo. So actually, we already discussed custom domain name binding in the previous demonstration, so let's just look at hot linking this time. We've already bound our domain name chinasite.xyz to our bucket. Let's look at how we protect against hot linking. So how do we keep people from linking to our bucket's content from their own web pages? Well, if you go under access control, there's this option here, hot link protection, and what you can do is set an HTTP refer whitelist so that unauthorized sites cannot directly link to the content of your bucket. This is especially useful if you're using OSS to host a static site. You'll also notice that for JavaScript, we also have a cross-origin resource sharing or CORS configuration that you can set up to resolve some common issues with JavaScript code and static sites. We won't go into that. Let's just focus on the hot linking for now. So I'll click on configure here, and you see I can configure a whitelist. So for instance, I can say China site.xyz is now on the whitelist. And I'm going to check this box here to also allow empty refers, because when I visit the root for my static site, the refer field is going to be empty by default. So I'll click save, and now if I were to visit my site, chinasite.xyz directly, everything works fine. My site is allowed to link to these images and there's no issue. In fact, if I were to open up the developer pane, reload the site, you can see that these two images here have their refer set to chinasite.xyz, which is in our refer whitelist, and therefore these images load up just fine. Of course, if I were to link to these images from another site somewhere else by directly referencing the image URL, it would fail. It would be denied because I've now configured this whitelist and only this site is allowed to link back to those images. And that's how you set up hot link protection on OSS. OSS security features. Let's take a look at some of the security features that are built into OSS. So the first is, of course, SSL or TLS. This is HTTPS security. This is encryption of data in transit. So there is an HTTPS endpoint for every single Alibaba Cloud region which OSS supports. So all of your data in transit can be encrypted via HTTPS. Access control, there's both bucket policy to set IP address whitelists and blacklists and set conditions on access like requiring HTTPS, and then there's bucket and object level ACL, which determines whether or not objects can be read or written publicly or will require a signing key. Then there's encryption for data at rest. We have two types of server-side encryption. One is SSE OSS, which is where you use a managed encryption key built into the OSS service. The other is SSE KMS, where you build or create your own key inside of our KMS key management service, and then you use that key to encrypt the contents of your bucket. Finally, there's identity and authentication. This is done via RAM and STS. STS is Alibaba Cloud's security token service. This is how you generate temporary access tokens that get appended to the URLs of objects in your bucket, which allow you to access those objects, say, from a web browser. And RAM is what you use to create sub-accounts under your Alibaba Cloud account. You can set RAM policy that determines which of these sub-accounts can access which buckets and which objects within each bucket. So you have fine-grained control over access to objects and buckets via RAM and the STS token service. So bucket and object ACL is something you configure at the time you create the bucket. There are basically three ACL policies: private, public read, and public read write. With a private policy, any access to the objects in the bucket requires you to sign your request. So you have to sign your request with an STS token. Public read does not require you to sign requests for reading the content of a bucket, but it does require you to sign requests to update, delete, or modify objects in the bucket. And then there's public read and write, which allows full access to read, write, and modify objects in the bucket without signing your request. That's a very dangerous option, and if you are using that, you should probably use it in concert with bucket policy. So bucket policy is here on the right. Bucket policy can apply to particular objects or to the whole bucket, and it allows you to set specific levels of permissions for RAM accounts, other Alibaba Cloud accounts, or anonymous users. And what you can do is set levels of permissions like whether the anonymous user, RAM account, or other account is allowed to read, write, and modify objects, and other conditions that the user has to fulfill, such as, say, the request might have to come from a particular IP address range, or a particular IP address might be blacklisted or banned. You can also set conditions on the access method. For instance, you could, through bucket policy, require a user to use HTTPS. To secure data in transit, you can use HTTPS. If you open the preview pane for an object in your bucket, like you can see in the screenshot here on the right, there's a radio button which you can toggle on to turn on HTTPS support, and then the URL for that object, which you can see in the box in the middle of the screenshot, will start with HTTPS, and any request to read that object will be encrypted using our SSL certificate. You can also, if you like, use a client-side encryption library to encrypt data before it's even uploaded to OSS, which will protect it both in transit and while it's at rest in the OSS service. So that's another option. If you require even stronger protection, you can encrypt and decrypt objects outside of the OSS service and then simply upload the pre-encrypted content into OSS. On the server side, in addition to the technique I just mentioned where you can encrypt objects locally before uploading, we also offer two encryption methods that are built into OSS, which I discussed briefly before. There's SSE KMS, in which key material from our key management service is used to encrypt objects. Then there's SSE OSS, which is where you use the default AES 256 key that's built into the OSS service. This is the easiest of the two to use, but KMS offers more customization and more security since you can use your own encryption key material. So for identity and authentication, there's two mechanisms. There's RAM policy and STS. So RAM policy defines which operations a user is allowed to carry out in the OSS service, and which buckets and objects those operations are allowed to be carried out on. That's the resource section in the JSON document shown on the left side of the slide. You can see here that the user is allowed to operate on any object inside the RAM test bucket, and that permission does not extend to other buckets. The user who is using this RAM policy on the left can only manipulate objects inside of the RAM test bucket, and at the top where you see action, you can see that they are allowed to do two things: list objects and get objects, which means that they can read the content of this bucket, but they cannot delete objects and they cannot upload new objects. So how is this access policy enforced? Well, when you make a request of the OSS API, you'll have to use your RAM user credentials to generate an STS token, which is a signing key. That key will be returned to your client, maybe your web browser, maybe the Alibaba Cloud command line tools, and you'll attach that STS token to your request to the OSS service. And what OSS will do is verify, number one, that that STS token is valid, and number two, that the operation you're trying to carry out matches the RAM policy. And if it doesn't match the RAM policy, the action is denied. So this is how we control access to objects and buckets in the OSS service. You can also generate time-limited signed URLs that point to an object in a bucket, like the one shown on this slide here. If you pass this URL to someone, they can use this URL to temporarily access a resource in OSS. Once the URL's signature expires, then the URL will no longer allow the user to fetch the object in question. So this is a way to offer temporary access, say, either to an individual user or to a third-party application or an application running on an endpoint like a cell phone. Time-limited keys are typically a good idea because they limit access duration and access permissions more effectively than a long-lived key like an Alibaba Cloud Access key. And that's all for this section of the course. Thank you.